You are already familiar with the concept of acids as substances that dissociate in water to produce hydrogen ions. You have also learned how we can express the degree of acidity of a solution using pH values. Let's carry out a simple experiment on two different acidic solutions. Beaker A contains 50 cm³ of hydrochloric acid. Beaker B contains an equal amount of ethanoic acid. Pour both acids into two separate test tubes. Add a piece of magnesium ribbon into each test tube. Click and drag the magnesium strip to the test tube. Observe what happens. Magnesium reacts vigorously with hydrochloric acid compared to ethanoic acid. Both acids have the same molar concentration. Let's check the pH value. Drag a piece of universal indicator into each of the solutions to determine their pH values. What inference can you make from this finding? The hydrochloric acid solution must have reacted faster than the ethanoic acid solution as it contains more hydrogen ions in the same amount of acids and water used. Hydrochloric acid is thus said to be a stronger acid than ethanoic acid. At the end of this lesson, students should be able to relate strong or weak acids with the degree of dissociation or ionization, conceptualize qualitatively strong and weak acids.
The degree of dissociation or ionization of an acid is the fraction percentage of molecules which dissociates in water to produce hydrogen ions. Let's calculate the degree of dissociation of hydrochloric acid. Click on the hydrogen chloride gas. Key in the number of hydrogen chloride molecules that you can see. Now click on the valve to pass the hydrogen chloride gas into the beaker of water. Type in the number of molecules that have dissociated. There are no acid molecules left in the solution. All of them have dissociated into hydrogen ions and chloride ions. The degree of dissociation of hydrochloric acid is 1 or 100%. The degree of dissociation of hydrochloric acid is 1. This is because all the hydrochloric acid molecules dissociate in water to form hydrogen ions and chloride ions. An acid that dissociates completely in water is called a strong acid. Therefore, hydrochloric acid is a strong acid. Let us now look at the dissociation of ethanoic acid in water. Click on the ethanoic acid to add it to the beaker of water. Look at the particles present in the ethanoic acid solution formed. The ethanoic molecules do not dissociate fully in water. A small amount of the ethanoic molecules dissociates in water to produce hydrogen ions and ethanol ions. The dissociation is reversible. That is, the ions transform back to acid and water molecules. In the case of ethanoic acid, there is a net of 4 hydrogen ions formed for every 100 molecules of the acid added to water. Thus, the degree of dissociation of ethanoic acid is 0.04 or 4%. The degree of dissociation of ethanoic acid is less than 1. We say that ethanoic acid is only partially dissociated in water. Note that a reversible sign is used in the equation to show that the dissociation of the acid is incomplete. An acid that is only partially dissociated in water is called a weak acid. Ethanoic acid is therefore a weak acid. Most organic acids and acids found in fruits are weak acids. Can you name some of the organic acids? We have learned that acids can be classified as strong acids and weak acids. The strength of an acid depends on the degree of dissociation of the acid in water. When a strong acid dissolves in water, all the acid molecules dissociate to form hydrogen ions. Thus, the concentration of hydrogen ions in the solution is high. When a weak acid dissolves in water, only a small amount of the acid molecules dissociate to form hydrogen ions. Thus, the concentration of hydrogen ions in the solution is low. Now let us compare the pH of some acid solutions of the same molar concentration to determine which acids are strong and which acids are weak. Drag the slider across the pH scale.
In this activity, you are required to identify the substance that best fits the description given. You are then required to click on the correct answer to see if you are correct. That's right. Determine whether the fault on the in this evaluation ready.
If you are but
In this lesson, you have learned that acids can be classified into strong acids and weak acids. The strength of an acid depends on the degree of dissociation or ionization of the acid in water. A strong acid is an acid that dissociates completely in water to form hydrogen ions. Its degree of dissociation or ionization is 1 or 100%. The concentration of hydrogen ions in a strong acid solution is high. Examples of strong acids are hydrochloric acid, sulfuric acid, nitric acid, and phosphoric acid. A weak acid is an acid that is only partially dissociated in water. Its degree of dissociation is less than 1. The concentration of hydrogen ions in a weak acid solution is low. Examples of weak acids are carbonic acid, ethanoic acid, and citric acid. Read the following newspaper cutting. A man had severe burns on his face and body when an unknown assailant splashed some acid on him just as he was about to leave home for work early yesterday morning. Using suitable references, find out how acids cause burns on human skin. Burns from acids can also happen when students accidentally spill them onto themselves in the laboratory during an experiment. Find out what you should do when this happens.